Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have these four equations and we have to find the area. We have to find the area that is bounded by the graph of these four equations. So, area of the region. Bounded by them. So, to understand the area, we have to first graph these functions and then we have an idea of what the area will look like, and then we have to figure out how to compute that area. So, why don't we pick a graphing utility and then graph this first function x plus 4 e to the x. So, let us try that. Y equals x plus 4 times e to the x and graph it. And you get an idea of what the graph will look like. Also notice that some x values are given, -2 and 1. So, you can also try to have your window set between those two values, so you know exactly what the graph will look like. And notice that looks like it's going towards x-axis. It's like that. Now, what about y equals 0? Y equals 0 is just x-axis. Okay, so this is the other function, that's the x-axis, because we have to find the region between all four of them. All right, next we have x equals -2. Now that is a vertical line through x equals -2. So if we consider -2 is somewhere here, okay, it's the vertical line. So say here is -2, and then x equals 1. So this is x equals 1. So the region bounded by all four of these graphs will be right here. And we have to compute the area of this region. Now, how do we compute area? Recall, area is, we have to integrate, okay? And inside the integral, we write down the expression of the upper curve minus the lower curve. So it's upper minus lower. And we have to figure out which one is upper, which one is lower, and we have to have some x values, right? X equals a to x equals b. So in our case, what is our upper curve? Well, clearly is the top one that we graph the first, that's the x plus 4 e to the x. That's our upper curve. And what is the lower curve? Well, that's just the x-axis, and the equation is y equals 0. So lower is 0. And what about the x values between the two x values that covers the entire region is -2 and 1. So this is the setup to evaluate the integral to compute the area of this region right here. So all we have to do is evaluate the integral now. Now notice this is a definite integral. This is a definite integral and the function is x plus 4 e to the x. As you can see, two different functions product together, so we can apply integration by parts. All right, so let's first evaluate the indefinite integral, and then we will plug in these limits and figure out the area at the end. So the indefinite integral of x plus 4 e to the x dx. So we have to choose our u and dv when we're applying integration by parts. Now there are two functions. One is this linear function x plus 4 and then an exponential function. Notice that either one can be differentiated or integrated easily. Now since e to the x you can integrate easily, let's choose e to the x dx to be dv, and let's choose x plus 4 to be our u. So u is x plus 4. So figure out du. So differentiate the right hand side, and that is 1 plus 0. So it's just 1 dx. And then dv is e to the x dx, which means v will be integral of e to the x dx, which is just e to the x. Okay. Now integration by parts says this is equal to uv minus integral v du. And let's rewrite everything. So u is x plus 4. V is e to the x minus, inside the integral we have v, which is e to the x, and du is just dx. So this is equal to integral of e to the x is just e to the x, and then plus c. You can combine these two terms together if you want. So there's a common factor of e to the x. So if you take that out, you will have x plus 4 and then minus 1. So this is just x plus 3 e to the x plus c. So that's the indefinite integral. But we have to evaluate the area, which is this definite integral. So what is area? One more time, area is integral from -2 to 1 of x plus 4 e to the x dx. And so we know our antiderivative is right here. So just use that and plug in the limits -2 and 1. Okay, so first plug in the top limit, the upper limit. So you have 1 plus 3 e to the 1, and then subtract and plug in the -2. -2 plus 3 e to the -2. So you get 4e, and here -2 plus 3 is 1. So there's negative of e to the -2. So this is our area of the region bounded by the graph of those 4 equations. Now, to finish this problem, we will have to verify our result using a graphing utility. So let's pick a graphing utility that you have. And first, let's figure out what this quantity is. What is 4e minus e to the -2? Okay, so four times e to the power 1 minus e to the power -2 is equal to, it's approximately 10.74. That many units. Okay, now we already have graphed this function. So let's go and graph. Let's plug in y equals, graph the x plus 4 e to the x, then also graph y equals 0, and then set your window between -2 and 1, then graph it. Okay. Now we have to figure out the area, and so we have to evaluate this integral right here. So go to Calc and go to integral of fx and enter, and then make sure that it's integrating the top function, not the bottom function. Okay. Now it's asking for lower limit, plug in -2, and then upper limit, plug in 1, and see it is shading this entire region that we found, and the integral is about 10.74. So it checks our result and it verifies that we have done everything correctly, and that is the area of this region bounded by these 4 equations. Thank you.